My name's Jake Morgan. I'm a creative developer and artist studying music technology at California Institute of the Arts. I'm doing my undergrad there. A lot of my research revolves around developing systems to kind of combine the world of 3D into the world of audio processing. So let's jump right into that. I won't waste any time. So we're all used to seeing a lot of one-dimensional and one-parameter knobs and sliders when we're either producing music. I know a lot of us are probably musicians here, and probably a lot of us are developing plugins. So we're all used to seeing this. The only problem is I find that the more complex our DSP gets, the more knobs we need. It's just kind of a necessary evil. So let's take Serum, for example, arguably greatest digital instrument of all time. I mean, I'm a big fan. But we can see that as our complex DSP and synthesis evolves, we need a plethora of knobs, menus, and things that can just kind of drive a user away. So I just think that professional audio tools like Serum expose incredible depth, but demand that you think like an engineer first and maybe a musician second. You're translating your creative impulses through layers of menus and technical abstractions. And I remember the first time I opened any synthesizer like this, I really gave up the first few times. It wasn't fluent, not because it was poorly designed. I think this is a perfect plugin. It's just the gap between the sound in my head and the technical knowledge required just wasn't bridgeable for me. So what if that interface could just meet us halfway? What if we could not really dumb anything down, complexity is power, just fundamentally rethink how we access complexity? So after 6 years of evolution, from analog knobs to really digital screens, we've kind of reached the limits of what 2D interfaces can kind of achieve and express. So we've gotten better at packing more into flat rectangles, but we're still constrained by the same paradigm. So imagine really just playing with audio like it's Play-Doh. And that can sound a little weird. I know we're grabbing it, stretching it, squishing it all in real time, but we can kind of move beyond these knobs and sliders into three-dimensional workspaces where a single interface object controls dozens of parameters simultaneously. So the tools for connecting 3D and audio have existed for like many years. It's just we've kind of been thinking in two dimensions for a really long time. Just picture controlling an entire effects processor or a synthesizer like Serum just with one intuitive object. Create complete creative control without navigating a single menu. So before I kind of show how this works, I think it's really important to just kind of mention that this builds on some already existing works, online gesture analysis for the control of audio processing and MediaPipe. I'm sure most of us here are pretty familiar with these. MediaPipe kind of showed that this kind of world of controlling a lot of parameters with 3D is possible just on consumer hardware with computer vision. So my kind of contribution is just kind of making the interface itself geometric. Instead of tracking external gestures to control abstract parameters, the 3D object is becoming the audio processor. So we'll rotate geometry, reshape the reverb, kind of change the mesh, change the actual effects chain. So let's kind of take a look at that. So I have a drum break prepared for us, nothing crazy, just pretty simple. So pretty cool, I like it. Let's run that through an audio sculpting. So I want you to imagine we are sculpting the audio. We are gonna start with a point cloud that it's pretty uniform, pretty round, kind of resembling a dog toy if you squint your eyes a little. Then we'll switch to something much more aggressive, something spiky, something that might poke you, something really aggressive. And I want to emphasize that the sound is going to try and reflect that. This cloudy, goopy object is not really. It's going to have what I would consider a round, cloudy effects processor. It's not going to do anything crazy, but it's going to reflect its sound and its shape well. And our spiky, aggressive object is going to do the same thing. It's just going to be really aggressive. So I'll kind of play that and let that speak for itself. So we're going to. So yeah, pretty simple effects processor, but we're going to switch to something spiky and see how that sounds. So pretty immediately, we're getting a connection between the way an object looks and the way an object sounds. So that still might not really make a lot of sense because this is a very weird way of approaching audio processing. So let's take a look at how this works. And I've kind of taken a top-down approach to looking at this. I don't want it to be very code-heavy. I want it to be very theoretical because I think anyone here could do this better than I can. It's just that we're taking an audio in. That's going to our audio processor. We're all familiar with this. It's going to have the GUI and the DSP that I kind of like write under my namespace termite. And I really want to emphasize that I'm leaving this DSP blank because I personally like really loud and noisy effects processors and effects change, and you might not like that. So I want to emphasize that you can do this with anything. This is completely open. You are just parameterizing some values, and we'll get to that in a little, but we'll look at the GUI for now. We're going to have a sculpt that's going to be sculpting our shape, whether that's from like an intuitive input, just as an overlay, or maybe you're taking a Blender file in, like a wavefront object file. That's going to go into our information retrieval. Don't worry about that yet. That's going to be a little complex, but we'll get there. That's going to go into our display. That's where all the fun is. So let's kind of dive into that. That's where all the meat is. Again, sculpting input, shape, information retrieval, don't worry about it. Display manager, awesome. We're gonna have interactive overlay. We're all familiar with this. We have the plugin editor. We're gonna be basically allowing maybe a user to upload their own Blender file, OBJ, maybe actually sculpt the shape real time, changing the audio, changing the shape. And we're gonna need OpenGL here. I'm not gonna go through all the binding of vertex buffers and the mess that OpenGL can kind of become. It's not really necessary to understand how this works. So we're just going to be taking OpenGL to handle more complex data and creating that point cloud, basically just allowing us to display what we're actually doing, allowing a user to understand that this 3D object is our sound. And that's just all going to go to our visual output. Nothing crazy, just what you see on screen. So we're going to look at information retrieval now. This is where everything happens. So, but first, let's think about how we describe objects. In this demo, we had a round shape, we had a stretched out spiky shape, and now all information retrieval is doing is really just describing the shapes that as we would for humans, like the way they look, just in the language or the context of the effects change, just kind of normalized values. And so let's look at how that works. Very basic step by step. We're going to take vertex extraction. We're going to parse our OBJ file. Now, if you're doing this more custom and you're kind of just assigning all the vertices by hand, you'll be doing extracting all your X, Y, and Z coordinates. You're going to move on to percentile sampling. You're going to take 10th, 50th, and 90th percentile values. And we'll map those to distribution patterns. We're going to take distance metrics, min, medium, maximum, distances from the origin. Our axis spread, we're going to measure the range between each dimension to determine the proportions of the mesh. Centroid invariance, this is where things can get complicated, but also very cool. We'll compute the center of mass and statistical variance to quantify some density and complexity. So in that example, I had that stretchy shape, not as uniform as that cloudy goopy shape. So we're going to get a much more intense like feedback network and more distortion with that. And then moving on, we're going to map all that to some audio parameters. We're going to normalize 20-ish geometric statistics into 12 audio effect parameters. Now, it's really important to emphasize these two numbers are completely arbitrary. You could have a plethora more of the geometric statistics, and you could also just have maybe one effect and have that modulate some very specific variables within your DSP, or the opposite, have one statistic and make it affect 100 different parameters. So this system's great, but I want to also just recap what we have so far, because we might now have a better understanding of what's actually happening. It might be able to understand how the sculpting works. So I'll play this back. This is going to be a new drum break, just different shapes. We'll start with the same one, and then I have kind of like a fun little shape that I think is funny to play with, and I'll talk through that in a second. Cool. Now, instead of maybe something uniform and like intuitive, let's use a horse. So don't use a horse. Yeah, it doesn't sound great, but you can do it if you really wanted to. So rather than focusing on like the visual properties of geometry, let's kind of focus on where it is in the space rather than focusing on how it looks. Now, this isn't really a new concept. This has been explored kind of with like spatialization plugins, like 5.1 stereo, placing sound within space to better pan and just place sound in three-dimensional space. But in this scenario, we're just going to be kind of parameterizing its location, its rotation, just for more intense reverb. So in this demo, I have an ambient piece I've prepared, and I'll be kind of playing with this object as a performance tool rather than kind of like setting in or dialing in like a good tone. And when I want the track to sound really far away, I'm just going to push the object far away. When I want it to sound close, just going to pull it closer. And I'll experiment with some different factors of like diffusion networks and maybe some cool feedback network as well. And when I want to like emulate a tape skip or maybe like play with the reverb chain a little, I'm just gonna spin it. I'm just gonna spin it around, basically emulating like if you've ever been around like a space echo, just if you hit it, it's gonna make the tape jump in place and the playheads are gonna get all screwed up. So let's take a listen to that. I'll let that play through. I won't bore you. We won't play that all the way through, but it is pretty cool. So just recapping, when I want the reverb to sound right in front of us, I'm just gonna bring it right real close to the screen. When I want it to sound far away, maybe it's like it's in a canyon or a tunnel, I'm just gonna push it far away. This kind of system of using this like placement rather than dialing in 8 knobs with like your reverb seems a lot more intuitive to myself, and I personally have been using this more than my normal reverb plugins and my normal reverb like workflow. I just kind of think, okay, I want the object to be, I want this track to be right in front of my face, but I do want it to have reverb. I just pull the object closer. So I also experiment with a little bit of like the fine-tuned parameters, like I was saying before, experimenting with different diffusion networks along the x-axis and then different feedback along the y-axis. And what's really great about this plugin is it uses the same exact system as the previous one. It's still using OpenGL as its main like display function, but it just follows the same exact flow chart. There's nothing really changing other than we're not sculpting audio. We're just seeing where it is. It's pretty intuitive to kind of like use this system. So it's kind of where can this go? Because I mean this whole like work and code exists in conjunction with a lot of my own art, as I am an artist, a lot of my practice and a lot of my aesthetic. It's very deep within like the way I create. So like within the rise of modern technology and like the AR space, maybe with Meta glasses, Apple Vision Pro, we can kind of further immerse the experience of these glasses kind of by using the concept of three-dimensional space as an interface, as a control system to push the boundaries of what's possible within these interfaces. So many interfaces within the AR space create two-dimensional interactive screens within three-dimensional space, kind of like a floating monitor, if you may. So if we have the ability to experiment with interaction in the 3D space, I do feel we 100% should be kind of using the AR space as our interaction point for the control processes. So if you were kind of wondering, where's all the code, there's way too much. I do have a repo of every single example that's been put together. You can go on this QR code. It'll have a repo with the example for the web app. That's that point cloud that does the mesh translation and allows you to sculpt audio, as well as the plugin source code. And you can compile that with a build script, whatever you need. It'll run itself perfectly. And you can kind of just go through and look at all these examples of how just 3D is our point of interaction. Because I think it's really important to just not really worry about the code itself here, because you could do this a plethora of ways. It's just kind of thinking about how 3D is our interaction space, because we live in a 3D world. Why not kind of play with that a little bit more in our two-dimensional, flat screens? So yeah, my name is Jake from California Institute of the Arts. If you like art, my Instagram is publicservices.web. You can find me at all my contacts here. And then if you really want to look at some code and you're really interested, go ahead and scan the QR code. There's a ton of code to read, I promise. Thank you, guys.